In this lecture, I want to talk about chance, credence, and the principle of indifference. So I'm going to start by drawing a distinction between two types of probability. The first is what philosophers call credences. And a credence is just a measure of your belief. It is sometimes called a subjective probability. The second type of probability are chances. So for example, the chance of a coin landing heads is 1/2. Now, let's start with an example. Suppose that there's an urn with 3 balls, a red ball, a blue ball, and a green ball. Now, suppose that someone selected a ball from this urn. So there's this urn. It contains these 3 balls, the red ball, the blue ball, and the green ball, and somebody selected a ball from the urn. And you have no further information about the urn or how the person selected the ball. Now, the question is, what credence should you assign to the ball being red? So I ask you, what is your belief that the ball is red? You have to assign a number to it. And the question is, what number should you assign to the balls that was selected as red? So you should pause for a second and try to come up with the answer for yourself and try to justify your answer. Why did you come up with the answer that you did? Now let's let R mean that the selected ball is red, and let C of R be your credence in R. This is your subjective probability that you assign to R, or a measure of your degree of belief that the ball selected is red. Now, many people say that your credence in R should be 1/3, should be 1 out of 3. Now, why do you think your credence in R should be 1/3? Sometimes people will say, because the chance of selecting a red ball is 1 out of 3. But that can't quite be right, because you don't know anything about how the person selecting the ball was choosing which ball to select. The person might select the ball by flipping a fair coin and choosing a red ball if it landed heads and a blue ball otherwise. So that means the chance is 1/2 that the red ball is selected. Yet most people believe, and naturally, it's a natural assumption, that the credence of R should be 1/3. Or maybe there is no chance process guiding the person's choice. And so you can't even make sense of the question, what's the chance of selecting the red ball? So if you think that your credence in R, your belief in R should be 1/3, it can't be because you believe that the chance of selecting the red ball is 1/3. It has to be for a different reason. Now, what reason is that? Well, the reason that most people come up with is some form of a principle known as the principle of indifference. So this is a typo, so that principle should be gone. The principle of indifference. Now, what is this principle? It says if there's no evidence in favor of A or in favor of B, then C of A should be equal to C of B. That is, the credence of A and B should be the same. So if you don't have any evidence in favor of one hypothesis or the other hypothesis, then the credences that you assign to those two hypotheses should be the same. So let's talk about this principle of indifference and think about how it might be applied. So let's change the situation a little bit. Suppose there's an urn with a red ball, but now we have 2 blue balls. We have a navy blue ball and a light blue ball. So there's 2 balls that are blue, but they're different shades of blue. One is navy blue, a slightly darker blue, and the other is just light blue. And again, someone selects a ball from the urn. So the question is, what's the credence that the ball is red? That is, what is C of R? Now, there are 2 ways you can answer this question. Here's one way of answering the question. There are 3 ways to partition the ball in the urn. There's a red ball, a navy blue ball, and a light ball. you have no evidence in favor of any of these different colors. So therefore, your credence in R should be 1/3, because there are 3 possibilities. You have no evidence in favor of any one of those possibilities, so your credence in R should be 1 out of 3. However, there's another way in which we can partition the balls in the urn. We can divide them into the red balls and the blue balls. And you have no evidence in favor of any one of those colors. The person could have picked a red ball, or the person could have picked the blue ball. So your credence should be 1/2. So the general question, when you apply the principle of indifference, the question you have to answer is, what's the reason to prefer the first partition over the second? Most people, when answering this question, will say your credence ought to be 1/3. But if you say your credence ought to be 1/3, you have to tell me, why do you prefer this way of partitioning the balls as opposed to this way? What makes this one better than the second one? And to demonstrate how difficult it is to answer this question, I want to talk about something known as Bertrand's paradox. And so here's the idea. Suppose that there's someone that has a square piece of paper. So it's a piece of paper, and you know that it's a square. So the length of all the edges are the same. Now you're told that the paper is not longer than 2 inches. So you don't know the length of the square, but you know that it's anywhere from, let's say, 0 to 2. So it could be 0, 1, 2. It can be any number between 0 and 2. And you're told no further information about the paper. Okay, so now what should your credence be that the paper measures no longer than 1 inch along its side? That the length of the paper is no longer than 1 inch. That is, the length is between 0 and 1. So take a moment and think to yourself how you would answer this question. You have a piece of paper, it's a square paper. The length is between 0 and 2, any number between 0 and 2. And the question is, what credence should you attach that the length is between 0 and 1? Well, here's one answer that many people give. The credence should be 1/2. The idea is that the length can be between 0. We're told that it can be between 0 and 2. The length can be between 0 and 1, so we're asking, what's the credence that the length is on the left-hand side of this interval right here? And the interval is divided into 2. There are 2 intervals. The interval where L ranges between 0 and 1, and the interval where L ranges between 1 and 2. And so the question is, so we've divided the interval into 2. You have no evidence in favor that the length of the sheet of paper is in any one of these intervals. You have no evidence to prefer any one of these intervals. So your credences should be the same. Since you divided the space into 2, that means your credence should be 1/2. However, there's another equally good answer you can give, and that is that your credence should be 1/4. So the idea here is, rather than asking about the length of a square, so here we have the length of a square, we're interested in the area of the square. And remember that the area of a square of length L is L squared. So the area, since our square is of length 0 to 2, the area ranges from 0 to 4. Now the key observation is that the length is between 0 and 1 if and only if the area is between 0 and 1. So if the length of my square ranges between 0 and 1, then my area will also range between 0 and 1. So the credence I attach to the area being between 0 and 1 is the same as the credence I attach to the length being between 0 and 1. Because after all, I have no evidence to prefer thinking about the square in terms of the length of its side versus the area. But if I think in terms of the area, note if the length of the square is between 0 and 2, the area of the square is between 0 and 4. But I can then divide my areas into 4 groups. 0 to 1, 1 to 2, 2 to 3, and 3 to 4. So, and then we have 2, the area is between 2 and 3, and the area is between 3 and 4. Since you have no evidence in favor of any one of these possibilities, the credences should all be the same. Since we have 4 possibilities, that tells me that the credence that the area is between 0 and 1 should be 1 out of 4. But of course, the area being between 0 and 1 should be the same credence that I attach to the length being between 0 and 1. So my credence seems to be 1/4. So Bertrand's paradox is, how do we resolve this conflict? We seem to have 2 equally good answers. The credence of the length of my square could be 1/2, or it could be 1/4, and we have no principled reason to prefer one answer over the other.